Hi everyone, welcome back to Dave's Math channel. I'm your host David Tare, and I was gone for about a week. I was on vacation. I just come back this afternoon. So now I'm continuing my feature on the Math Lovers book, which is a 3-volume series I wrote from 2019 to 2022, which is available on Amazon.com for those of you who are interested. You can buy any one of these volumes or all three or any combination thereof. Available both paperback and in Kindle. But I'm going through this series in this channel, at least the first 2 volumes, and I'm up to chapter 5 of volume 1. I'm on section 5.4, I believe, which is on functions. And this is my 5th video on functions, and today I'm going to talk about a special type of function called cyclic functions. So anyway, let's begin. So what is a cyclic function? Well, last time I was talking about composition of functions. So remember, you have like f of x, and then you have f of x, which I was writing as f with a superscript of 2 in parentheses, f sub 2, superscript 2 of x. That would be just f composed with itself twice. And you can do that as many times as you want. You can have f of x, that's f superscript 3 of x, and you can keep going. And what a cyclic function is just a function such that if you compose it with itself some finite number of times, you get back the function you started with, or you get back x. So you get the identity function, basically, after a finite number of compositions. And functions that are equal to the inverse, I think I talked about these in my last video last week. Example, this would be f of x equals 1 over x. If you compose that with itself, you get back x. 1 over x is x. So this is an example of a cyclic function of order 2. And so any function like that that's equal to its inverse is a cyclic function of order 2. But we can have cyclic functions of other orders as well. And here's an example, a little more complicated example of a cyclic function of order 3. So suppose we started with the function f of x equals 1 over 1 minus x. So that's a little more complicated than 1 over x. Still an example of a rational function like 1 over x, and it's still hyperbola if you graph it. But anyway, let's just see what happens when we compose it with itself. So if we do it once, if we compose it with itself once, we get f superscript 2 of x, which is in other words f of x, and that's 1 over 1 minus f of x. And now if we substitute f of x into this fraction, we get 1 over 1 minus 1 over 1 minus x. And if you simplify this expression, which is a Fermat algebra, I'm not going to go through all the steps here, you end up with x minus 1 over x. So you don't get back the function yet, but let's do it one more time. So if we do it a third time, f superscript 3 of x, this is going to be 1 over 1 minus f superscript 2 of x. But now f superscript 2 of x is x minus 1 over x. And if you do the algebra, simplify this equation, you do indeed get x back. So this means that this particular function, if you compose it with itself 3 times, you get x, you get the identity. So that's a cyclic function of order 3. So that's basically what cyclic functions are. They can have arbitrary large order. I haven't seen any cyclic functions with order, I think, bigger than 5 or 6. So they're pretty rare. But that's what they are. Anyway, that completes my video for today on cyclic functions. Thank you for watching. Long live math, and I'll see you guys next time. Bye.